Midas NFX Lecture 10 Part 2 Joule Heating Transient Analysis. Open a case. Give it a name. Import the geometry. Step 2. Material. Will include a solid tungsten. And for the electrical conductor, the resistivity is 5.65. 10 to the minus 8. And the alpha is 4.5. 10 to the minus 3. And the reference temperature is 20 degrees. And I'll connect the geometry with the material. And this is the end of step 2. Step 3. I'll choose the geometry and accept the default mesh size. Step 4. I'll impose a voltage of 0, ground the top surface, and give a current to the bottom surface of 1 milliamp. And convection for all the surfaces that it's in contact with the air, except for the top and bottom surfaces that are in contact with the electrodes. The reference temperature will be 20 degrees, the ambient temperature, and the convection coefficient is 10 for stagnant air. And this is the end of step 4. And step 5, I'll choose transient CFD analysis and edit the control, analysis control. For solid heat transfer, there is electrical field, and I'll change the step size to be 0.1 second. So totally 1000 second will be 100 1000 step will be 100 second total interval time. And the gravitation is on z-axis. And I'll define the initial temperature of the solid to be 20 degrees C. And also I'll check the thermoelectric effect. So for the analysis control, I choose solid heat transfer and check electrical field effect, and give initial temperature to the solid and check the thermoelectric effect. So these are the things, the control items that I have entered. So I'll save the file before I run the solution phase. So I start to run solution, and I'll stop recording. Stop recording. Although the iteration is still running, the temperature is stabilized, so I will load the result file. This is a favorite feature for me in Midas, and we can look at the result while iteration is running. And this is the result. I can extract the temperature here and show the table and make a graph out of it. The x-axis will be the number of steps, y-axis will be the temperature. And you can see that the temperature rises from 20 degrees C to 102.5, and this is the steady state temperature, right? We just as we did in the first part of this lecture. So you can see that What is a steady state analysis? It is when the time goes to infinity and the system becomes stabilized. For transient, it is a process of when time equals to 0, the system changes to a stabilized condition. So this is the transient process. So this is part B of lecture 10, the transient analysis for Joule heating problem.